So today we try to working with the bipolar transistor. And the bipolar transistor, they get that two part. First one will be talking about the DC. Okay, that means the power, whatever need for the transistor to work it. And the second thing, the transistor will be using as the amplifier. Okay. So any question, just stop me, let me know. First thing, is you say that is a symbol for the what we call a NPN transistor. We already done with a diode. Diode, that means PN junction. So basically, NPN, they get a two diodes combined to make a transistor. And in the bipolar transistor, you get two different types. One they call a NPN, and another one we call a PNP transistor. So when you're looking into the schematic, you're able to recognize, is it a NPN or PNP transistor? Okay, now see what the difference. For the NPN, this arrow point out. However, PNP, the arrow will be pointing. That is the difference. Okay, and they get the three terminal. One we call a base, collector, and the emitter. Same thing. Okay, base, emitter, and collector. Okay, the formula normally you will be using. That means you can see the current. They get the three different current. One IB, that means the base current. IC, collector current, and IE, emitter. So for NPN, IB coming in, IC coming in, IE will be leaving. So that's why you get the formula. IE equal IC plus IB. Okay. And now they say if IC and IE almost equal, that's only telling you they don't care much about current IB, the base emitter, the base current, too small. Okay. And only thing is the formula apply to both NPN and PNP. Only thing to see the difference. If for the PNP, IB will be leaving. Okay, go out. IC also say going out. However, IE emitter current going in. Okay, that is the must memorize. Okay, when you see the transistor, you have to know which one is the base, collector or emitter. And also how the current flow in NPN and PNP. Okay, for NPN, B coming in, IC in, IE out. PNP, IB leaving out, IC leaving, IE coming in. Okay, and also you can get another two definition in here. Alpha will be equal IC divided to IE. Basically, IC, IE very close. So alpha can be almost equal to 1. And the beta that means the amplifier, okay, of the transistor. And the beta equal IC divided to IB. And the beta can be changing from 50 to 300. And that make up by the manufacturer. That means when you get a transistor, they already telling you what beta equal. I given you example. Beta equal 100 for this transistor. So if you get IB equal 1 milliamp, then the current IC will be 100 milliamp. They want to amplify it. Okay, make the current bigger. And the current IE also a little bigger. The thing with ICIE, almost very small difference. Okay, for this part here, any question? Okay, so it is easy we go next. That just given you the physical of the transistor. Okay, basically we don't care much thing. However, I try to explain to you. This is the P side of the silicon transistor. And this is N side in the middle. And P side, that means transistor here will be P and P. Okay. And on that one, then one side they can be collector, one side they can be emitter, in the middle will be the base. They already telling you collector, emitter, in middle here will be the base. That will be PNP construction. And now for NPN, then now just the opposite. This N side, and P side in the middle. So you can get an emitter here, collector here, and the base. Okay, so this is the symbol here. When another section P or N type material is added to a PN diode junction, a 3-section device contains 2 junctions is formed. That means PN or PN, NP or NP make up the transistor. Okay, in here, they will be telling you this is a transistor, okay, NPN, okay, so you can get collector, emitter, or the base, same thing, just simple. And you see that collector here, base here, emitter here. So number 1 will be emitter, number 2, the base, number 3, collector, okay. And basically, if you're looking inside the schematic, this is the base, this is the collector, and this is the emitter. Basically, they get a 2 diode. One diode from the base to the collector, and another diode from the base to emitter. On this one, they just opposite. Okay. So basically inside the transistor, you understand for the base to the emitter here, you get one diode. And the base here to the collector, you get another diode. Okay. That means two diodes make up the transistor. This one, they just telling you how to test the transistor. This is from the textbook. Okay. Basically, you connect this symbol for the diode. Okay. Positive connect to the base and the negative connect to the emitter. Okay. So basically, you get around 0.7 volt, 0.65 somehow. That means, okay, it's working. And now revert it. Okay, you get positive to the emitter and the base to the ground. Basically, they get a bigger voltage. So I don't want this thing. You can try that when you're doing on the lab. However, normally the way they want to do is they want to testing for diode forward bias. So basically, on this one, I want you to connect and to measure the ohm, measure the resistance. Okay, then the positive connect into the emitter and the ground connect to the base. Basically, they can reading the voltage of the resistance. For example, read 2K kilo ohm, and now you revert it. Okay, revert the connection here, and they read 100K. They're telling you the diode working. And you can test for B and C. Okay, that means the ratio between the forward and the reverse bias, they have to be 1/1 to 100. That means for forward, you measure 1 kilo ohm, and the reverse, they have to be higher than 100 kilo ohm, 100 times different than the transistor working. So,
Mr. Fan, I have a question.
Yeah, go ahead.
Without using a multimeter, without measuring the resistance, how can we say it's a base emitter or collector?
Oh, how can you see, right?
Hmm.
You see right here. When you're looking at the transistor, pin 1 will be base. No, emitter. Pin 2 will be base. Pin 3 will be collector.
But is the pin number 1, 2, 3 written on the transistor? Because transistor very small, we cannot.
You can see that easy. When you're working on a transistor, this is a transistor, then you're able to easy to recognize pin 1, pin 2, pin 3.
So all the three pins are same in length or they are different in length?
What do you mean in length?
The legs are same in height length or they differ in length? I'm talking about the legs. 3 legs transistor have.
Right. 3 legs, if you're looking into the transistor, you're able to recognize which one is what.
Okay, which one is emitter, base, and collector? Okay, thank you.
Is it by the length that you're saying? Like 1 is the second longest, so that's collector, 2 is the shortest, so that's the base, and the longest is 1.
Yeah, I don't care much about that thing. However, when I'm looking in the transistor, okay, based on this one right here, I can recognize which one is 1 or 2 or 3. Easy.
Because of the length, like an LED light. One as the positive, one is the negative because of the length. That's the way that you recognize it, Mr. Pham?
No, I not recommend about the length here. This longer, this shorter.
Yes.
Okay, but I not recommend. By you looking into that, okay, and the symbol right here, you take the transistor and you easy to recognize which one is the one. Okay.
So the notch one leg, the notch one, there is a notch. Am I right?
Right. You know
That
the
is
one. Then in the middle, you know that will be 2.
Hey, Mr. Pham,
Yeah.
on these transistors, from what I've noticed, it's pretty simple. They're labeled 1, 2, and 3. So if you know which one is which, in other words, the transistor that you were pointing to, it will be labeled 1, and then it'll be 2 and 3. It'll be printed on there for them. So
No, they're labeled.
I'm sorry.
Different
They're
type.
labeled. Cool.
Different type.
Yeah, right.
One you normally see in the lab, they put number 1, 2, 3.
Correct.
Okay.
Okay, thank you.
What?
Thank you.
You're welcome. Okay. The transistor cannot be working without the DC power supply. The job of the transistor will be amplifier. What they want to amplify? They amplify your voice. That means the sine wave AC signal. Okay. That means the AC signal applied in the input, output at the collector here, they're supposed to be bigger. Okay. So your voice will be louder. That is the job for the transistor. However, without the power supply DC, they cannot work it. Okay. So now we're talking about DC bias. DC bias, that means we're talking about power supply, how they working with the transistor. So in this circuitry here, you get 2 power supply. One will be VBB and another one VCC. And also, you're looking into the circuitry, you see RB. What stands for RB? What does stand for RB?
Base resistance.
Base.
Base resistance.
Base resistance.
RC means collector resistance. And sometimes you can get a one here, RE, but not in this schematic. Okay, so now if you're looking into how the current flow on PNP, first thing you get a VBB, then you get the current flow here will be IB. Okay, IB flowing here, and when they go in here, okay, that means IE will be equal IB. And also you get the current IC, collector current from VCC, go in. So that's why IE equal IB plus IC. For NPN transistor, the way current flow you must be follow, cannot change. IB have to be go in, IC going in, IE going out. and also reverted PNP. And PNP will be using negative power supply here, negative power supply here, okay? However, the current will be IE coming in, IB leaving, and IC leaving. Okay? This is the thing you must be memorized. We cannot help you. If I show you the transistor, you have to telling me which one current coming in or which one current leaving the transistor. And now, this is the one they want to do basic calculation. So this is the VBB right here. Okay, we're talking about NPN, VCC. And in here, from the base to the admitter, you get a diode. Also, you understand from the base to the collector, you get another diode. Okay, and the diode using silicon, that means 0.7 volt. So for sure, if you want the diode, this diode on, the V from the B to the E, VBE, must be equal or higher than 0.7 volt. If less, this diode will be open. Okay, so now in order to do calculation, so they can give you the equation. That means you draw the loop, okay? And that's why you can get minus VBB plus IB times RB plus 0.7 volt equal 0, okay? And finally, they given to you IB equal, okay, right here. In order to calculate the current IB, you're using this formula. VBB times VBB, BE divide RB. VBB, whatever they given to you, and the VBE, that means from the base to the admitter, you know, 0.7. And that is the value for RB. That you can calculate the IB, okay? And after you can calculate the IB, you can calculate the IC. IC equal beta times IB, depending on what value of the beta they given to you. Okay? And after you get the IC, you can calculate the IE. At the beginning, I can tell you, IE equal IC plus IB. But that formula, not really good to calculate the IE. So that's why they come up with IE equal 1 plus beta times IB. That we prefer that formula to calculate the IE or IB. And now also you understand one more thing. When they using capital letter, that means for DC, okay? Later on, the lowercase they telling you, that will be for AC only. So if you want to do calculation, you can using this formula here, okay? If you want to calculate the voltage at the VC, then basically you need to know what the voltage drop across RC. Okay, VRC equal IC times RC. And if you want VC, then VC equal VCC minus IC times RC. And finally, if you want to calculate the VCE, then you take your VC minus VE. Okay. So this is the own formula you need to do the job. Basic calculation. Normally, now we get the simulation program. You draw the circuitry, you run the telling you everything you want to know. What IB, IC, IE, VC, VB, VRC, VRB. Okay, no big deal. But basically, you need to know in order to talk to the people and also in order to do basic calculation for the study. Okay, and question, anything. Try to understand the lecture and try to working on the real lab. If you know what to do, how to do it, you will be a very, very good technician.
Hey, Mr. Pham,
Yeah.
I don't know if you want to do it or not. On the part on the right, can you put in the pluses, minus? I'm trying to see how the loop looks.
On the right.
Yeah.
Yeah.
Where's it? Yeah. Can you put like plus minus in the loop so I can see how it looks?
You mean here, right? Plot here, right?
Yeah, all of that big loop. If you just go around and put a plus
Yeah,
minus.
you don't need that. You can do. Go ahead, draw this way. Right?
Okay,
That plot here minus here
right.
will be VRC.
And then RC, okay, that's plus, that's minus.
That VRC.
Okay,
Okay?
all right.
VCE. Now, how do we draw loop? First thing, arrow go to the negative. Right?
Right.
Then you can get minus VCC. Okay?
Okay,
And when you hit into the RC, positive, negative, and the voltage here will be plus IC times RC, correct?
okay,
And this is the VCE, positive, negative. So you plot VCE equal 0.
okay. Yeah, that's what I was looking for. Okay, thank you, Mr. Pham.
Yeah. So VCE on this part, they equal 0. Right? Connect to the route. So now you just only get the minus VCC plus IC times RC equal 0. So in this formula, if you want to calculate the IC, you move VCC to the right. So you can get VCC, right?
Mhm.
Okay. VCC, okay, divide. Now,
No. You want to move the VCC to the other side of the equation, and then you'll be left with IC times equal ICRC, and
Okay.
then
Okay, you can get IC time RC, right?
right equal VCC. Now you divide both sides by RC, and then RC on one side will cancel out, and IC will be by itself.
Now, this only apply if the voltage VCE equals 0. Okay?
Mhm.
If the VCE not equal 0, then you have to using minus VCC plus IC times RC plus VCE. Okay?
Okay,
And they're telling you, okay, VCC will be a minus VCE divided to RC. And this formula only apply if they grounded at meter.
okay.
Okay, anything else?
Yes, teacher.
Yeah,
So transistor is a device used to amplify with gain as beta, right?
you're talking about amplify, right?
Yep.
We're
Because
not talking about amplify AC signal. We're talking about DC amplify. What that mean? You get a current IB equal 10 milliamp, for example. Okay, and they gave it to you beta equal 100. They're telling you, I see beta time IB. So 10 times 100, 1,000 milliamp. That is the amplified DC current, nothing to do with AC.
okay,
Okay,
but if we put a sign in the circuit of the base,
yeah, that later.
okay,
Right now, we just deal with the DC bias.
okay,
How to make the transistor working.
okay,
Okay, nothing to do with AC. So
okay.
basically, this is just an example. Okay, so can you spend a little few more minutes? Go ahead and do it for me. I want to know to see how many people can be applied the formula we just gave it to you. At least you have to do one time. That's what they're talking about, DC bias. How the transistor can be working. Remember, nothing to do with amplify. Go ahead and do it for me, okay? If you understand, you can do it quickly. Try to get the answer for me. I don't want I have to do everything for you. Keep talking. And basically, finally, you couldn't get anything. The diode we be using will be silicon. Silicon means 0.7 volt. Especially for the student already been here from last spring. You're supposed to get it done, no matter what. The thing is you guys already get through it. You can do without looking into any information. That is good to me. If you still have to open the book, the note, whatever, that's not really. What I said when you interview, you don't have anything with you. You have to do it quickly. They want to know you understanding or not. Who done everything, let me know, then we can go through it. If you're not doing anything, to go on.
So what you're saying is we should be able to memorize all these formulas, right?
Normally, when you're looking into that, you know right away what formula. Otherwise, in the field, they just asking very basic thing here. How can you do? More you exercise, you will be okay. How come I know right away? The reason is I'm teaching long time, go over and over and over and over. So that's why I don't need any formula.
Got you, Professor Pham. I'll try to be like you eventually.
Someday, exercise, keep doing basic. That's what I'm talking about, basic. Not try to solving a difficult problem. We don't care. But some basic must be done.
Yeah, it's just practice. You just got to keep doing it over and over.
Exactly. My learning for my life is what reading over. The thing is when you're reading, they go into your brain. You never know. Up to a certain point, you understand everything. Even it's too late for me. When the time I be in the university, I didn't know. So the first thing VBE, you know, that will be right? Easy.
0.7.
And the formula calculate the IB.
VBB minus 0.7 divided by RB.
4.93.
5 minus 0.7 divide 10K.
4.93.
Okay, now you get the 4.3 divide to 10,000. And you get 4.3 times 10 power minus 4. That means you get 0.43 milliamp. Okay, and the beta they given to you right here, 150. Okay, IC equal beta times IB. That equal 150 times 0.43. Okay, 0.43 times.
Milliamp.
You get
64.5.
is it 64.5? 0.43 times 150. 64.5. Okay, so you get 64.5. Okay, you want to calculate the IE. What I already said, using formula 1 plus beta times IB. Okay, so 1 plus beta means 151 times 0.43. Okay, 0.43 times 151. You get 64.93.
Quick question. How do you know beta is 150?
That's what I show you here.
Oh, it's just given.
Yeah, they given. You cannot make it up. That's from manufacturer. And now telling me what VB equal.
Should just be IB times RB.
VB. Now, what is VB? VB means voltage from the base to the ground. In this case. Okay. General definition for VB. That means the resist voltage from the base to the common. In this case, you don't have a RE. So that VB will be from
BE.
B to
Yeah.
the ground.
0.7.
0.7.
7.
Correct. That means you just measure across the diode. VE
0.
0. They connect directly to the ground. VC. That means right here. Formula VC equal VCC minus IC time RC. You need to know VC IC time RC. You need to know this one. We call it VRC. Okay. And this one VRC. Equal IC time RC equal IC 64.5 time 100 ohm. Okay, 64.5. 64.5 is a milliamp. So the resistance must be changed to the K kilo ohm, 0.1 KO. Okay, they must be converted to kilo ohm, so they cancel for the milli. Okay, 64.5 times 0.1, 6.45. Volt. Okay, finally, VCE. By basic definition, VC minus VE. VC we already calculate 6.45. VCE means 0. So 6.45.
Mr. Pham,
Yeah,
I think VC is supposed to be 3.55
okay, now. Oh, sorry.
because it's
Yeah, I know.
okay. Thank you.
VC equal VCC minus VRC. And this is the VRC. Okay? Not the VC. So you want the VC. Then VC equal VCC minus VRC will be 10 minus 6.45. Okay, 10 minus 6.45, 3.55.
3.55 exactly. So that's it.
And that will be 3.55. Yeah, thank you. Make sure every time they given this kind of circuitry and you can do calculation quickly. That is, I want it. Okay, any question?
Mr. Pham, and the base to the ground was that was the 0.7, right?
Back to the round VB,
Yeah, 0.7.
0.7,
Mhm.
right here.
Hey, normally there'll be like what is it when you call VBB plus or minus?
What's the
So-
VDD? Where we get VDD?
No, B as in boy. Well, forget it, because they don't have a resistor in the emitter. Forget
Yeah,
it. Thanks a lot.
They don't.
They
If they
don't.
get a resistor, that's a different.
Right.
But now we're working on no emitter resistance. Okay, any more questions up to this point? We go through step by step, make sure it's clear for everyone.
I have a question.
Yeah, go ahead.
Beta, how big can be the beta? How big can be 100, 1,000?
He's asking how big can beta be? How big can beta be?
Okay, thank you.
I already telling you, beta equal 50 up to 300. That's the manufacturer.
Yes,
Given to you.
depend on the manufacturer, right? Okay.
Yeah. From 50 up to 100 and now 300 during in that range. They can be 100, they can be 50, they can be 200, whatever.
Okay.
Yeah, we are of control.
So you're saying that the manufacturer makes beta from anywhere from 50 to 300, and that's what you would get on basically all transistors?
Right.
Okay, thank you.
Yeah. Okay. Now, region of operation. Okay. Transistor can be working. First thing, they will be in cut-off region. They using for the switching application. That means like switch to turn on, turn off. Active, that means used for amplified. Linear amplification. That means amplify your voice. And the last saturation. Same thing, used for the switching. That's the three things will be happen for the transistor. They can be cut off, they can be amplified, or they can be saturation. Okay. And the last one they're talking about breakdown. We not want to do it. That will be destroy the transistor. That means you apply more current, too much current. Now, they will be telling you in the cut-off operation, the diode from the base to emitter will be off. They're telling you, you get a diode here. Okay, B to emitter. If they're not working, they open, that will be cut off. If they not working, then the current IB, IC, IE will be equal 0. They open inside the transistor between the base emitter and collector. So no current can be flowing. Okay, active region. That means you want to using transistor for the amplification amplifier. So they say the diode from the base emitter is on, and the diode from base to the collector will be off, okay, or reverse bias. Okay, so only this one on, this one will be reverted bias. Then they will be working like amplifier. And saturation, both diodes will be on. That means if they working in the saturation, this diode and this diode also be on. And the voltage here, VC to E, almost zero. That is what the thing you need to know when they're talking about operation. They can be cut off, they can be active, they can be saturation. So what cut off they're using for switching, okay, on and off. And also that will be using for saturation. Only thing you want to say the transistor active, you want to build the amplifier, okay? Now, for this circuitry here, for the transistor circuit show, what is VCE when Vin equals 0? What VCE? That means the voltage here. VCE. When input 0. Telling me. You understand that will be collector. That will be ammeter. And that will be base. VCE from collector to the ammeter. What that voltage equal?
VCC to ground.
What VCE equal if the input 0 volt?
Symbol.
It equals VCC to ground. VCC.
VC minus VE.
Now you know. V in 0 volt. The transistor what?
Off.
Okay. That will be telling you IB equal IC equal IE 0. Correct?
Correct. No, if it's
current.
right, no current.
Correct.
Transistors off.
Okay.
Symbol.
Open.
Yeah.
Okay, if you want to get the VCE equal VCC minus IC times RC. And IC, you know, they equal 0.
Yeah.
So equal VCC.
Symbol.
So basically, they will be equal 10 volt. That's what they given to you right here. I make sure you understand why they 10 volt.
Yeah.
Zero time any number is zero. So then you don't have anything on that side from the current.
So Mr. Pham,
Yeah,
in this instant, the transistor is therefore in the cutoff, right?
exactly.
Okay.
Cut off IB, ICI is 0. No current flow. Okay, now that question a little confused. What minimum value of IB required to saturate the transistor if the beta equal to 100? Okay, that one I already given you the answer. We can go to that. Try to read to understand. Since transistor is saturated, we already know when they saturate, VCE equal 0. So you can calculate the current IC, but IC saturation, that will be equal VCC divided to RC. 10 volt divided 1K, you get 10 milliamp. Okay, so they said therefore IB equal IC divided to the beta. And IC we just doing calculation will be 10 milliamp divide beta they given to you 200. So that's why you get IB equal 50 microamp. That is the minimum value of IB required to saturate it. We suppose they already saturate. That will be telling you VC to VCE equals 0. Okay, then you can calculate the current IC saturation. Take the VCC divided to RC, you get 10 milliamp. And after you get the IC saturation, now you can calculate the IB saturation. IB equal IC divided beta. IC saturation 10 milliamp divide beta 200, given you 50 microamp. Okay, that's the minimum. Calculate the maximum value of RB when Vin equal 5 volt. That now they given to you Vin equal 5. And what they want? They want RB. Okay, I can go to that question. When the transistor is on, voltage across RB, that means voltage here, VRB equal Vin minus VBE. That means you want the voltage from here, RB. Okay, basically, you can take the Vin, okay, minus 0.7 volt for this guy. And that's what you get 4.3 volt for RB. That means the voltage across B resistance. And now, if you get the voltage across that one, okay, you can take the VRB divide to the current IB. We just do calculation here. That given to you 86 kilo ohm. Normally, if you go to the college, you have to do little more calculation. The thing is, most of in the college, they go by theory. Okay, not that quite different from this program compared to the college. Way more practical. We know what the technician in the company doing. So that's why we go by that way. See the college instructor, sometimes professor, they never working in the company. And they basically don't know what technician doing. So that's why they keep going more theory. But I'm already talking the professor in the city college. You guys behind at least 10 years. Now, how come you need to go too many details on that calculation while you get a simulation program? Simulation program telling you anything you want. You're supposed to teach them how to deal with the problem. That's what technicians have to do.
Teacher, I have a question.
Yeah. Go ahead.
Okay, in letter C, if the transistor is on, why we are using the current 50 microamp if this current is when the transistor is saturated?
You go working, asking about A or B or C.
C.
Which one?
Why use 50 microamp if this one is for transistor in saturated?
You're talking about number B, right? Milliamp.
Yeah. No. Why we use 50 milliamp to find the 86 kilo ohm?
Okay. You want to calculate the IB.
Okay.
Then IB equal IC divide beta. Correct?
Yep.
And now you want IC. In here, IC already equal VCC divide RC. Okay, so that will be 10 volt divide 1K. Volt divide kilo ohm. You must be get milliamp. That unit conversion. So that's why you get 10. If you don't understand, then now you have to take 10 volt divide 1K mean 10 to ohm. 1 times 10 power of 3. Then you have to convert it back to the milliamp.
I understand.
Easy way, when you divide voltage or current to resistance. If resistance in kilo ohm, then current will be in milliamp. Voltage have to be millivolt.
I understand this, teacher, but it's not that I'm asking. I asking is why you use in letter C, right? To find the RB max, right? You use
RV max.
okay. Why you use 50 microamp?
Why? How come we get 50 micro?
Yeah, micro.
Okay, you get the current IC 10 milliamp. Now I need to calculate the current IB. That's why IB equal IC divided to the beta. That beta 200, IC is the 10 milliamp. That's how come they come up with 50 microamp. The thing I cannot telling you, how come? The thing is you get IC, I want to calculate the IB.
Yeah, I understand this.
IB equal IC divided to the beta. That's the formula.
Yeah, I know that.
That's why I said to try have to do over and over. One time you cannot understand. Do it thinking. Why that happened will be help.
Okay.
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 Okay. So I will be stop here tomorrow continuing. And Sam,
Yes, Mr. Pham.
can you help me to run the screen number 2?
Yes, sir.
Okay. So we'll be talking to the guy tomorrow on date display. Okay. Okay, make sure they must be download the report.
Fam, so I go to the website and where do I find the report? Under which tab?
Under the handout.
Gee, man.
Oh, okay, I go to handouts. Which
Sam
one do we go
saw
to
it.
now? Huh?
Let I talk Sam show him again. Later on, you have to get along with the way we do it.
Go to the website. Go to the handout.
I'm already there.
Right here. Why can you not see it?
Oh, I just didn't know which one you were talking about.
Well, we did number 1. Now it's number 2. It's
Okay,
logical.
thank you. Okay, thank you.
Okay. All right. So everyone, make sure you download that. Okay. So let me go ahead and share the screen. Okay, so we're going to go. All right. Okay, can everybody see?
Yes.
Okay, thank you. Okay.
Said earlier to December 2022 before the midterm elections without a number on how much they want to raise. That has nothing to do with past spending. That has everything to do with future spending because they're
Bye, Mr. Pham.
Bye.
Thank you. Good night.
Good night.
You see, missing number 10. Let me go back to number 10. Let me look at that just 1 second. Okay. Share number 10. Okay, Sabrina, can you see that? Sabrina? Sabrina, can you see number 10?
Maybe she went home.
Okay, sounds good. Okay. Sounds good. All right. So make sure you upload it to the website, please. Okay.
Okay, good night, everyone.
Good night.
Good night.
Good night.
Yeah.